Hi everyone, today we're going to be talking about solving radical and exponential equations. So our first steps just to solving radical equations are, there's 4 steps here. So step 1, you're going to isolate the radical on one side of the equation. Step 2, you're going to raise each side of the equation to the power of the index to eliminate the radical sign. Step 3, you're going to solve the remaining equation, and then we're going to do step 4. We're going to check for extraneous solutions. So those are the steps. Let's go over an example here. So for our first example, it should be a radical. So your example is going to be the square root of 6x minus 5, and then outside of that radical is going to be plus 10 and then equals 3. So what we do here, our first step again, we're going to isolate the radical to one side of the equation. So we want to make sure that just this portion right here is by itself, so that we can take the square root. So let me show you how to do that. We're going to subtract 10, and now we see that we have the square root of 6x minus 5 equals a negative 7. So we do have that square root by itself. We are going to now raise the side of the equation to the power of the index to eliminate that radical sign. So in this case, remember, it's a little invisible too, and you could do this with cube roots or fourth roots. You would raise it to whatever power the actual index is. So in this case, it's a 2. So we're going to go ahead and square those so they cancel each other out because they are inverse operations of each other. So I'm left with 6x minus 5, and then do negative 7 times negative 7, which is a positive 49. Now we're just going to finish solving this stuff for x. So that's what solve the remaining equation by adding 5 to both sides. So we have 6x equaling 54, and then we're going to divide both sides by 6, allowing x to equal 9. Okay, so now the thing we need to do is check. Our last step is to actually check for any extraneous solutions. We want to check to see if this actually works. So this is me checking my work, and we are going to plug in that 9 back into this square root for the x. And I will show you what we are looking for. So plus 10 equals 3. Go ahead and do the 9 times 6 inside that radical first, so we get 54. Then we're going to just minus 5, still have that 10. So 54 minus the 5 is going to be the square root of 49 plus 10. Square root of 49 is 7. And then so I'm not doing my plus or minus because that square root was already in the equation, so I don't have to actually take the plus or minus of that. So right now it says we have 17 equals 3. So that actually is not a solution. That is not going to work. So this is actually no solution here. So we solved for it, did not get the value when we plugged it back in, this making it no solution as our final answer here. Alright, for our next example, we are going to be taking the square root of 19 minus x, this is all under the radical, and this is going to be equal to x plus 1. Get a little bit more difficult here. So again, get your radical by itself. That's the first step. I already have the radical by itself, so I'm going to raise it to the power of whatever the index is. Again, it could be cubed, it could be the 4th power. Just these 2 examples I happen to be doing squareds. So these cancel each other out. I'm left with a 19 minus x. And then you remember we cannot just distribute this 2 to here because of this plus sign right there. That makes our life a little bit more difficult. We have to do the x plus 1 times x plus 1, and we are going to be distributing now. So I'm going to go through and distribute x times x. We get x squared. X times 1, we get our 1x. 1 times x again, we get our 1x, and then plus 1. Combine like terms before we start solving for our actual x variable. So this is 2x plus 1. And then now from here, we are going to go through and get our equation to equal 0 on one side. So I'm going to subtract 19. I'm going to do this in one step, you guys. I'm going to just get this whole left side over here, subtract 19, and add x. I'm doing the opposite, the inverse of each of those. So I can get a 0 over here, and then I have an x squared still, and a 3x this time, minus 18. So now you can see that I have a polynomial, the quadratic. So we need to be looking for doing our work with the AC method. We need to be factoring this, so I'm going to do a little side work over here. So I'm trying to figure out a number that when multiplied will get me to negative 18, but then that's going to add to 3. So I know that 6 and a negative 3. 6 minus 3 get me 3. 6 times negative 3 will get me negative 18. So I'm going to use the trick here. Actually, no, I'm not, because I remember that most of my students don't get the trick. So let's rewrite our new b values. And we are now going to determine our GCF of those first two terms, which is just x, and I have an x plus 6 left over. The GCF of my last two terms here is just a negative 3, so I have an x plus 6 left over as well. This is the GCF, so I'm going to take that out, so I have an x plus 6 as one of my factors and an x minus 3. So from here, you guys, this is where we would actually go through and solve, set these each equal to 0, and we're going to solve for x to see what our actual options for plugging back in would be. So I'm going to subtract 6 from both sides on that one. I'm going to add 3 to both sides on that one, so I get x equaling a negative 6 here and an x equaling 3 here. Again, our last step, we actually have to check for any extraneous solutions. So I'm going to plug in this negative 6 first. So if I plug in negative 6 back into our original equation, I have 19 minus a negative 6, and then equals a negative 6 plus 1. So 19, negative times a negative is a positive, so I'm now adding 19, 19 plus 6, so we get the square root of 25. Negative 6 plus 1 is a negative 5, so I'm going to take the square root of 25, and I get 5 equaling a negative 5. That cannot happen, so this is false, that this will be no solution for this one right here. I will not get to use it as part of my solution, so I don't get to use this value. Now I'm going to plug in 3 for this one. So I'm going to erase so I have more room. So far we got 5 equals 5 does not work. It's no solution over here. Let's try the x equaling 3. 19 minus a 3 equals, and then we still have our 3 plus 1. So 19 minus 3, we end up getting the square root of 16, and then we get 4. We know the square root of 16 is 4. Again, I'm only using the positive value because I did not add that square root in there. It was already there. So this is the this actually does work because 4 equals 4. So then our only solution for this value is only going to be 3. So 3 is the only number that worked. When we plugged it in, we actually got a number equaling a number. When we plugged in that negative 6, we got 5 equaling negative 5. It does not work. So 3 is our actual only solution there. Okay, we're going to move on to the steps for solving exponential equations. So your first step, you are going to be solving or isolating the term with the exponent. So just like the radical, but now we're trying to get our exponents by itself. And then you are going to raise the side of the equation to the power that is the reciprocal of the exponent to eliminate it. Step 3, you're going to check for extraneous solutions again. So for our first example, this time it's going to be an exponential form. So we are going to be working with, let me change my color here, we are going to be working with negative 36 equals negative 9 parentheses x minus 12, and we're going to go to the 1/2 power. So we need to get this exponent, this portion right here, the one with the exponent, by itself. So that means I have this negative 9 that I need to get rid of. So I need to divide both sides by the negative 9. Negative by negative is a positive. And then these cancel out, divide out, x minus 12 to the 1/2. Now I have my exponent by itself. So now I'm going to raise this entire thing to the reciprocal of what it is. So the reciprocal, I'm flipping these, which is just 2 over 1, but 2 divided by 1 is just 2. So I'm just going to raise everything to the second power. So 4 squared is 16. These, I was just going to show you, 2 times 1 is 2, 2 times 1 is 2, so 2 divided by 2 just turns into 1. So we're left with x minus 12 left over. Now I'm going to finish solving for x by adding 12, doing the reciprocal. I end up getting 28 equals x. Our last step is to actually check for our extraneous solution here. So this is me checking, and I'm going to plug the 28 back into the equation, and we are hoping that it will equal the same side, the negative 36. 28 minus 12, and then we're going to bring that to the 1/2 power. So negative 36, simplify and use PEMDAS, you guys. 28 minus 12, we have our 16 to the 1/2 power. So remember, this is why it's so important, you guys, to be converting from radical form to exponential form. I don't want to simplify in exponential form, I need to simplify in radical form. So this is the square root of 16. Oh, I actually see how I can simplify that. And again, I did not add the square root, you guys. This means I have a square root here, so I just have a negative 9 times the square root of 16, which is 4. And then when I get negative 36, negative 9 times 4, we get negative 36. So yay, check, this is our actual solution. So we get to mark x equaling 28 as our final solution. Let's go on to our last example for this set of notes. We have the, I'm going to actually show you using a different radical this time. So 7p, let's use a different variable too, and to the 1/3 this time. And we're going to plus 11 equals 7. Okay, so let's get our exponent by itself. I need to subtract 11 this time, so I have 7p minus 1 to the 1/3 equals a negative 4. And then I have my exponent by itself. I am now going to multiply the whole thing by the reciprocal. Just raise everything to that 3rd power, or 3 over 1, either way. These are going to divide out to the 1. So now I have 7p minus 1 equals negative 4 to the 3rd power. Actually, let's simplify that right now. So negative 4 times negative 4 times negative 4. We're going to be left with the negative because we have that odd exponent. And 4 times 4 times 4 is 64. Now I'm going to go ahead and get my variable by itself. We are going to add the 1 to both sides, making it negative 63. Divide by 7, leaving me with p equaling a negative 9. Oh, and we don't know if that's the answer or not, so we don't get to box it. We now have to check our work again. Let's check to see if I plug in that negative 9, if we will get out with a 7. So 1/3 again, and then plus 11. Again, you guys saw how we had examples that it actually did not work out. I'm not using my PEMDAS rules like I told you guys to do. So let's use PEMDAS. 7 times negative 9, we end up getting, and then minusing 1, we end up getting our, so 9 times 7, we have our negative 63 minus 1 more, we have a negative 64. All still to the 3rd power. Plus 11. Now we're going to do our exponents. Remember, this is the cubed root of a negative 64, so I'm trying to figure out the number that multiplies by itself 3 times to get me negative 64. And I know that that is a negative 4. Negative 4 times negative 4 times negative 4 gets me right back to negative 64. Plus 11. We are hoping it will equal 7. So when I go ahead and add negative 4 plus 11, we end up getting 7 equaling 7. Check. P equaling negative 9 is our final value. Alright, you guys, we will be practicing these when I see you in class. Please have questions ready so that we can go over anything that you guys don't understand. And I will see you then.